2005 National Electrical Code, or NEC, outlines specific requirements for grounding electrodes. While it permits the use of cold water pipes and ground rods as grounding electrodes, it also mandates the installation of a concrete-encased electrode at each new building or structure. Let's delve into the details of these acceptable grounding methods and the specifications for the concrete-encased electrode. Firstly, concerning the concrete-encased electrode, this electrode must adhere to certain dimensional and placement criteria. It must be at least 20 feet in length. This length ensures adequate contact with the earth, providing a reliable path for fault current. The electrode must be buried at a minimum depth of 30 inches. This depth helps to protect the electrode from physical damage and ensures that it remains in contact with moist soil, which enhances its conductivity. The concrete encasement itself plays a crucial role in protecting the electrode from corrosion and maintaining a stable electrical connection to the surrounding earth. The NEC specifies the type of concrete to be used for the encasement. It needs to be a mixture that provides adequate protection for the grounding electrode without compromising its ability to function as a grounding path. Secondly, regarding cold water pipes as grounding electrodes, there are specific requirements that must be met. The water pipe must be metallic and in direct contact with the earth for at least 10 feet. This ensures that the pipe can effectively serve as a grounding electrode. The water pipe must be electrically continuous. Any insulating joints or sections of non-conductive pipe must be bridged with a bonding jumper to maintain electrical continuity. There are limitations on using cold water pipes as grounding electrodes. In some jurisdictions, their use may be restricted due to concerns about corrosion or the potential for the pipe to be disconnected or replaced with non-metallic materials. It is essential to verify the local requirements and restrictions before relying on a cold water pipe as a grounding electrode. Thirdly, ground rods can also be used as grounding electrodes. Ground rods must be at least 8 feet in length and must be driven into the earth to that depth. Multiple ground rods are often required to achieve a low enough resistance to ground. The NEC specifies the minimum spacing between ground rods, which is typically at least 6 feet. This spacing helps to ensure that the ground rods are effective in dissipating fault current. Ground rods are typically made of copper or copper-clad steel, which are conductive and corrosion-resistant materials. The NEC also addresses the grounding electrode conductor, which connects the grounding electrode to the electrical system. The grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor for various service entrance conductor sizes. The grounding electrode conductor must be securely connected to the grounding electrode using approved methods, such as listed connectors or exothermic welding. The grounding electrode conductor must be protected from physical damage. Where it is exposed to physical damage, it must be installed in conduit or otherwise protected. The purpose of a grounding electrode system is to provide a low impedance path to ground for fault currents. This helps to protect people and equipment from electrical shock hazards. When a fault occurs, a fault current will flow through the grounding electrode system back to the source of power. This will cause the overcurrent protective device, such as a circuit breaker or fuse, to trip, interrupting the flow of power and preventing a dangerous electrical shock. A properly installed and maintained grounding electrode system is essential for electrical safety. It helps to ensure that fault currents are safely dissipated and that people and equipment are protected from electrical hazards. In summary, the 2005 NEC provides specific guidelines for grounding electrodes. It accepts cold water pipes and ground rods, but mandates a concrete-encased electrode for each new building or structure. The concrete-encased electrode must be at least 20 feet long and buried at least 30 inches deep. Understanding these requirements is crucial for ensuring electrical safety and compliance with the NEC. Remember to always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements.